last time we were together, we learned how to solve equations that were in factored form, and we also were introduced to the vertical motion model. So let's see how we're doing with all of this so far. Number one, how many seconds till it lands on the ground? Chris, Edgar, Valerie, what'd you get? Okay? 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 Well, you all said three different ways of saying the same thing. Usually when we're talking about time, we usually tell time in a decimal or a fraction form. 1.25 seconds, 1 1/4 seconds. Outstanding. Number two, all I asked you to do was solve the equation. What'd you get? You got Dalton, Kadir, Nathaniel.
0, 2 and 2.
Okay?
B equals 0 and 8 and 8 over 3.
Okay?
B equals 0 and 8 over 3.
Okay? B equals 0 and 8/3, which is the same thing that Dalton said, just in a different form. So let's take a quick look at number one. Can someone read me their vertical motion model after you put in all of the information? What was it, Stephanie?
0 equals -16 t squared plus 22.
Give me a thumbs up if that's the model you wrote out for number one. Good. Lots of people. Very good. Nice. Why is there no term right here? Because I know the model has a term there, but why is there nothing here? Sebastian R?
Just equals 0 and
Oh, very good. Now, I actually think it's a flaw in my question that I didn't realize until after I wrote it and put it there, is that I don't know if it's realistic to think that a fountain will start from the ground. Because usually, if you go to a restaurant, they have a fountain out front. It's a big concrete structure with the middle raised off the ground. So I think there's a flaw in my question. But I was intending it to be 0. So you guys interpreted it correctly. Okay? I just don't think it's the most realistic question I ever wrote. Yes? I was talking about a decorative fountain. Okay. Okay, well, the water definitely comes from that level, but I think whenever it hits the part that shoots water out, I think would usually be raised up. But it doesn't matter. My intention was for the starting point to be 0. Yes.
I would guess that would be one of those fountains where since it's like 20 feet per second, and that's about almost the height of a modern house.
You're misinterpreting that information. Velocity is measured in feet per second. That's not a height. That's how fast it's moving. Okay? So that's not necessarily how high it's going. Okay? It's traveling 20 feet per second. It doesn't even have to travel a full 20 feet. It can travel 10 feet in half a second. That's its speed. Okay? Very good. All right? So any comments, questions, or concerns about number one? Good. Excellent start to the day. Okay. Today, we're going to take what we learned last time and go a big step forward. Today is going to be a challenge for a lot of you. And it's a little bit of a process to help you get to where we need to be. So it's going to take a little time. Eventually, I promise you, you will get it. But it requires effort, it requires thought, and it requires focus. So, let me rewind for a second. Today we're going to learn how to factor a trinomial in this form. Let me rewind. Last time, we learned how to solve an equation that was in this form. And we learned how to deal with this. We subtracted this from both sides, and we ended up with a binomial. All of the ones that we solved were binomials. So we only learned how to solve one particular case. Today we're going to expand that knowledge dramatically. And you are going to learn how to solve an equation that's in this form. And we use a method called factoring. Factoring means to take a polynomial and write it as a product of its factors. And the factors are usually binomials. So to do this, we need to go back to something you learned before. So if everyone will start on the left, and you should have this written down. But I do not want you to do anything with it, and I don't want you to worry about any of the other ones. Now, I would like, for now, to multiply this. What method do we have at our disposal to multiply this? Val. FOIL. I do not want you to write anything. Put your pencil down. I want you to look at that multiplication problem, and I want you to see if you can FOIL it in your head. Give me a thumbs up when you think you've got it. Okay? All my people who have their thumbs up, don't do any work. I want you to write down underneath what you think it's going to be. Just write it down. Don't cheat and do F and then the O and then the I and the L. I want you to write down the answer. And we'll see if you got it right. All right, here it is. So give me a thumbs up if you were right. Wow, it's actually much more than I thought that it would be. Good, put your thumbs down. My students who don't have their thumbs up, who have no idea what's going on, just watch. Because in about 5 minutes, you're going to get it too. So Dalton, you claiming that you were able to do it mentally? Okay. Well, how did you get the negative 15? Okay. How did you get this? Okay, and in this case it's what? Right, but what is the front half of each binomial? Yeah, it's just x times x. So figuring this out is easy. And figuring this out wasn't hard either, right? So the only hard part is really the middle term. Let me go further. What's the beginning of each binomial for these other two examples? Kadir? It's x times x, and then it's x times x. What's the first term going to be here? Kalasia, what do you think it's going to be? What's the first term going to be here? So that's easy, right? Good. So Dalton also told us what the last term will be. We can figure out the last term. So the hard part is just figuring out how to do the middle term. So now I'm going to give you another shot, see if you can figure it out. I want you to look at this middle example right here. You are not allowed to write anything. I want you to FOIL it mentally and give me a thumbs up when you think you've got it. Okay, put your thumb down and write it down. Let's see if you got it right again. Okay, here it is. Give me a thumbs up if you got the first one wrong, or you didn't even know how to do it, but you got the second one right. Put your thumbs down. So now let's try and reveal a little bit. How do you get the middle term? How do you get it, Alexandra? Well, you've got lots of language at your disposal. We have the FOIL method. We have FOIL. We've got the words polynomial, binomial, trinomial. We've got lots of words to use. So try to compose your thoughts. I'll come back to you in a minute. Okay? Add the last two terms. Okay, so what do you mean? This and this? So this plus this. Okay, and that comes out to 3. Did it work on the first one? Worked on the first one too? Okay, Dalton?
What I found is when you do x times x, that's when you get 2, and then you multiply 2 times 1, and you get the back number, but you just combine the two expressions to make 2x and 1x, and you add them together.
That's right. So she said a little bit of a shortcut for what you just did, and you're both right. The only thing with yours, Michaela, is yours doesn't include the x, and you have to. So what he's saying is we're combining, and this is where Alexandra was struggling with the words, you're combining the outer and the inner. Here's the outer, x times 2, that's 2x. Here's the inner, 1 times x, that's 1x. So now we have a 2x and a 1x, put them together. That's where you get the 3. What Michaela is saying is that she realized that it's just adding the 2 and the 1, and then you put an x next to it. That's basically what's happening. Add the 5 and the negative 3. You get 2. Put an x next to it. So now everybody in the room should have at least a good chance of getting the last one. So now I want you to do this last one mentally. Don't give me a thumbs up. Just write down what you think it is right when you're done. All right, let's see if you got it right this time. Give me a thumbs up if you got that one right. Okay, now I got a lot of people. Good, put your thumbs down. So I have a good news, bad news situation. The good news is you guys just made a big giant leap. The bad news is that's not today's lesson. That was something you already knew how to do. What did we just do? You just did FOIL. The only difference was you did it in your head instead of on paper. So that's not new. Now here's the new. Now we have to look here and learn how to go in reverse. So now I would like you, do not do anything over here. I want us all focused right here. Everyone write 2 empty sets of parentheses, and underneath it write x squared minus 5x minus 24. Now, let's see if you can go in reverse. You now have to figure out what must go here and here to get this. I want you to do it mentally if you can. Give me a thumbs up when you think you've got the 2 binomials. Thumbs up when you think you've got them. A little bit harder. Okay, I got 4 people, 5, 6 people, 7, 8 people, 9, 10 people. 11. Okay, all of a sudden I got a whole bunch of people. All right, put your thumbs down. And this time, write in the binomials that you think are the correct ones. This is the giant leap. If you don't get it yet, it's okay. You will eventually. Let's see if you got it right. Keep in mind that it actually doesn't matter which one you have in which position. These are interchangeable. So let's see what you got. So give me a thumbs up if you were actually able to figure it out. Pretty humongous leap that you just made. Put your thumbs down. If you didn't see it yet, let me give you a little bit of a clue with your classmates' help. What is the connection between this number and these two numbers? What's the connection? Chris? Okay. So -8 and 3 are called what? In relation to the -24. It's a fancy word for it. Not really that fancy. Yeah, they're factors. So the connection is that these two numbers have to multiply to this number. So now here's the hard question. What's the connection between this number and these two numbers?
When you add them together, it equals -5x.
That's right. When you add the two numbers, then you get this number. So there is a specific connection between these two numbers that you figure out and the numbers that are here. So you have to be aware of that connection and use that to find the right combination. All right, let's see if you can do it again. Now the middle one. Little bit harder. Take a moment to see if you can figure it out. When you think you've got it, write it down. You don't have to give me a thumbs up anymore, just write it down. All right. So you've been given a chance. Let's see if you figured it out. Here are the two binomials. Keep in mind that you could have the x plus 2 over here and the x minus 1 over here. But one thing I want you to be aware of is this would be incorrect. If I put x plus 1 and x minus 2, that is actually incorrect. Because 1 times -2 is -2. But what is wrong? Fung? Yeah, when you add them, it comes out to -1. And this is a +1. So this is incorrect because it produces the wrong middle term. So you have to be careful about your positives and negatives. So give me a thumbs up if you were able to get that one. Good, even higher rate of success. Not everyone though. Let's see if we can get everyone on board. Figure out this last one. All right, let's see if you got it. That one was actually a little bit easier because you didn't have to worry about, positives and negatives. Everything was positive. These two numbers multiply to 56 and they add to 15. These two numbers multiply to -2 and add to +1. These two numbers multiply to -24 and add to -5. Which brings me to what the goal is, which is to find two numbers that multiply to C and add to B. So just to see it, these are the two numbers. They multiply to C and they add to B. That's what we're trying to do. So I had you do a lot of things mentally on purpose. Now we're going to actually do a little bit of writing with our ultimate goal to be able to do these things pretty quickly, mostly mentally. Okay? Bless you. Does anyone have any comments or questions so far? All right, so now we're going to do some formal examples. And we're going to go slowly on the first one, and then we're going to accelerate as we go along. So we're going to pick up a lot of speed. So for the moment, all we are doing is factoring. We are not solving equations yet. But this is our goal. Our goal is to be able to do this. Our goal is to be able to solve this equation, this problem. Our goal is to be able to solve that equation. Factoring is the method that's going to help us. So right now, I am just focusing on how to do the factoring. So, the goal for factoring this trinomial is that we need to find two numbers that multiply to this. So here's the actual process that you're supposed to be going through. We're going to do it on paper. You're supposed to take the 60, and we need factor pairs for 60. Can someone give me a factor pair for 60? Any factor pair at all? Alexandra? 10 times 6. Beautiful. 10 times 6. Give me another factor pair for 60. Nathaniel?
5 and 12 is the answer.
5 times 12. Thank you. Give me another factor pair for 60. Davis?
30 times 2.
30 times 2. Very good. Give me another factor pair for 60. Dalton?
11 and 6. What?
Not 11 times 6. Sorry. Stephanie? 20 times 3. And in fact, with all of these, when you talk about a positive number, it could be -10 times -6. It could be -5 times -12. But here's the thing. We have to find the factor pair that actually adds to this number. So now we have to go through and find which pair adds up to 17. Luckily, the hard work was done for us by an enthusiastic young person in the back who figured out that that is the factor pair. So, factoring this trinomial, we use those two numbers. It'll be x, and we just fill in the 5 and the 12. For now, it actually does not matter which one goes where. And this is factored form of this trinomial. Comments, questions, concerns? Yeah, well, in the cases we're doing, we're going to be using integers. So we're not going to see any situations with decimals, although you won't see any with decimals, okay? But it is possible to do it. All right, any other comments or questions? All right, part B. We start with the number in the C position, the 39. So what we're doing is we're making factor pairs for 39. Give me a factor pair for 39. Zumar? Negative 13 times negative 3. Sebastian R., give me another one.
3 times
13 times 3. So you always have the ones that are opposite each other. Good. Give me another factor pair for 39. Michaela? Oh. Okay. Kadir? 1 times 39. Don't discount that. That will come into play at some point. Nathaniel?
2 times 17.
2 times 17 does not come out to 39, unfortunately. It comes out to 34.
10 times 3.9.
Okay, well, when we say factor pairs, we're looking for whole numbers. Okay, integers. All right, so is the factor pair that we need already listed for us?
Yes.
Okay, Daniela, which one is it? I'm sorry, I can't hear you at all. Okay, negative 13 times negative 3 will add up to negative 16, so that is our factor pair that we needed. So here is the factored form. We've got x and we've got x. Now we're going to have minus 13 and minus 3, and that is factored form. Comments, questions, concerns? Nathaniel, Michaela.
When I said 2 times 17, it's actually 3 times 19.
Okay, but again, we've covered now from 3 different people that we're not talking about decimals. We're talking about whole number integer factors. Whole number integer factors. Okay? All right. Part C. I'm sorry, Michaela, go ahead.
I noticed the way you place it, you put the smaller number first.
Just coincidence. It doesn't have to be. They are interchangeable. Okay? Part C. So we start with this, the negative 64. Now it's going to look a little bit different. That's why I'm doing extra examples. Give me a factor pair for negative 64. Edgar, and then in the back. Okay, so since it's a negative number, one of the factors has to be positive and one has to be negative. John?
Well, I was going to say that, but 1 and
Good. 1 times negative 64, or it could be negative 1 times positive 64. Okay? What else, Danielle? Negative 4 times 16. Matthew? Or it could be positive 4 and negative 16. Very good. Is the factor pair that we need already up on the list?
Yes.
Okay, so someone raise your hand and tell me which one is it, because I don't know which one it is. Valerie, which one is it? 4 times negative 16, let's see. 4 times negative 16 adds up to negative 12. Very good. So that is the right pair. So now we are ready to write in factored form. So we've got x, and we've got plus 4 and minus 16. And that is factored 4. Any comments, questions, concerns? Edgar? Well, you tell me, can it? So you're suggesting can we use that pair? Okay. Well, it multiplies to negative 64, but does that add up to negative 12? It doesn't meet the requirements, so unfortunately we cannot use that one. And it has to be this one. Okay? So, but he's illustrating an important point, is you have to be careful. All right, I had another example, but I don't think we need it, so let's see how you do on your own. Checkpoint number 1, factor these two. You got 2 minutes. All right. What'd you get? Good, lots of confidence. That's what I like to see. We'll start with Stephanie, Feng, and then Daniela. Okay, what'd you get? Okay, so I think that's the same thing. Okay, so it is x minus 6 times x minus 5. Make sure you're not saying and or anything like that. It's x minus 6 times x minus 5. You're multiplying those two factors together. What about part B? What'd you get? We'll start with Chris, Valerie, and then Kalasia.
X minus 4 times x plus 3.
Okay. Okay, so that is the same thing. You just flip-flop the two. Okay, Kalasia? Good, you all got the same thing, and that is correct. X minus 4 times x plus 3, or x plus 3 times x minus 4. It doesn't really matter. These two numbers multiply to negative 12 and add to negative 1. Comments, questions, or concerns? So, the whole purpose was not to just be able to factor. That doesn't get us anywhere. The purpose was to be able to solve an equation. And so that's what we're going to do now. Is we want to be able to solve equations that look like these. You learned how to solve equations in factored form last time. Now we're going to factor again and solve the equation. Now, there was one thing that was true last time when we solved equations. All the equations had one major thing in common. What was one major thing that they had in common that we actually had to address towards the end of the lesson last time? Kadir? Very good that you picked up on that. They all equaled 0. So the only way to actually make it work is if the 0 is on the right hand, or on one side, but usually we put it on the right. So what do we need to do to get rid of this to get the 0? Davis?
Add 5x to both sides.
Very good. So we'll add 5x to both sides. This will disappear, and that's where we'll get our 0. And now this term jumps to the other side, and we're going to put it in standard form. X squared plus 5x minus 14. Now, last time we were together, you learned how to solve an equation that looked like this. I could show you the lesson from last time. It was the first example. It was a binomial times a binomial, and we learned how to solve by setting each binomial equal to 0. So now we just need to get from here to here because we already know what to do after that. And today you learned how to get from here to here. The first part is easy. We already know it's going to be x and x. Now we need two numbers that multiply to this and add to that. What are the two numbers? Got lots of people that know. John? Okay, Sebastian R.
-2 times 7.
Yeah. 7 times -2 multiplies to this, and when you add them, it adds to this. 7, -2. All we have done was converted a dollar bill into 4 quarters. That's all we've done. We have not done anything with the 4 quarters. Now we need to actually do something. Now we set each binomial equal to 0. X plus 7 equals 0. And x minus 2 equals 0. What are the two values for x? What are the two solutions? Edgar? -7 and 2. And what that means is that these two numbers are solutions to this equation. And if I plug both of these back in, it will make a true statement. Watch this. Let's plug in the 2. 2 squared is 4, minus 14. -5 times 2 is -10. Is that a true statement?
Yes.
Yeah, it is. Now let's try the -7. -7 squared is 49. Minus 14 equals -5 times -7 is 35. Is that a true statement? Yes, it is. Both of these work. So that's an important connection. Here's the last connection. Last time, and it was quick, so you may not have paid too much attention to it, but I did show you what the graph of one of these looks like. Does anyone remember what it looks like? Fun? Up and down, like up and down?
No.
Okay, what was the shape? What was the shape of it? Nathaniel?
It dips twice, like You know how all those hard meters go?
Yeah, well that was a special one that I showed you. It wasn't one like this. What was the first one that I showed you, Danielle? Yeah, it was just a U that looked like that. But Fung was right. It crossed at two positions, here and here. And so these are the two positions that the graph of this one will cross. That one will cross at -7 and +2. So in fact, it will look something more like this, where it will cross at +2 and then -7 all the way over there. -7 and +2. Okay? Good to hear.
Just like for the graph, how do you know like if you're above the x or the y or below?
You're going to learn that next time. Not next time, in Chapter 10. Chapter 10 is when you're going to learn how to do all of this, but it's an important connection, so I'm showing it to you. Okay? Other comments, questions about this one? Good. Let's solve another and make sure we're understanding the process. The connection between the last lesson and this one is this, that you already know how to solve an equation that looks like this. So we want to turn that dollar bill into 4 quarters. This is the dollar bill. I want to turn it into its 4 quarters. That's what we're really doing, is we're just changing the form. 4 quarters is still the same value as a dollar bill, but the 4 quarters you can go to the vending machine and put them in and get something out. So, we need two numbers that multiply to -45. But those two numbers also have to add to 4. What are the two numbers? Danielle? -5 and 9. Let's see if that works. -5 times 9 is -45. Yep, it does work. -5 and 9. Now, solve. We have not solved yet. We have not done anything with our 4 quarters. So now we solve. X minus 5 is 0. X plus 9 equals 0. What are the two solutions to this equation? What are the two solutions? Sebastian C? 5 and -9. And that is solving an equation. Any comments or questions or concerns? All right, let's see how you do on your own. Checkpoint number 2. You've got 2 minutes. thumbs up if you figured out the solutions. Okay. Put your thumbs down. All right. Kalasia, Alexandra, and Sebastian C. What'd you get, Kalasia? Okay. 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 The correct answers are -10 and 8. Doesn't matter the order. 8 and -10 and -10 and 8 are the same thing. So I gave you one a little bit trickier than the previous two. What was the first thing you had to do? And here's where a bunch of you are going to kick yourselves because you didn't realize. Danielle? You had to subtract 40 from both sides because you need that 0 over here. This disappears and you get your 0, and here's what you end up with. X squared plus 2x minus 80 equals 0. From there, you can factor and solve. Okay? Comments, questions, concerns? You guys are doing a very good job so far. Now we're going to apply it to a higher level real world scenario. When I put up the question, you are to read the question, don't copy it, but then you need the diagram. So read, copy, diagram. So the scenario is building something, a flag. The diagram is set up. It's kind of a generic diagram. And we're given the amount of fabric that's going to be used to construct the flag. It's going to be 117 square inches. So when you're talking about constructing something like this, and we're given information here and here, what basic math idea are we really talking about to begin with? I'm not talking about something from my class. I'm talking about something from your earlier experiences. Dalton? Perimeter. So the fabric is going to only go from here to here to here to here and back. The fabric's just going to go around the edge. No? So it's not going to go from here to here to here. It's area? Okay. Michaela, do you agree with that? This right here, that's W plus 2. Yeah, it didn't come out very well. Okay? So we're talking about area. Nathaniel, you think it's area or do you think it's perimeter? Or do you think it's something else? Okay, so area is what we're talking about, and to figure it out, we need the length times the width, or base times height. It doesn't really matter. So what is the length of this flag? What's the length? Chris? Well, W plus 2 will get us from here to here. Is that the whole length? Okay, you want to modify it? Go ahead. Nope, W plus 2 is from here to here. Okay, so you originally thought that this 2 was this 2 over here? Okay, so that's understandable. So you think it's W plus 4. And yeah, to go from here to here, the whole thing is W plus 4. And the width is W. So now we need to do length times width. So, length times width. But what does the area have to be? What does the area have to be? Zumara? Yeah, we're given a requirement of 117 square inches, so this has to equal that. Now, this is factored form, but factored form only works if this is a 0. So we can't use this form because this is not a 0. So now we could subtract 117 from both sides, but now we're left with this. Which is okay, but I still don't know how to solve that. We haven't learned how to do that yet. So we actually have to kind of multiply things out to get the correct polynomial that we need. So, I know some of you are tired and you've been working pretty hard, but you got to stick with me for a little while longer so we can finish out the real goal of the day. Okay? So what needs to be done, it's kind of a roundabout process. We're going to have to kind of go backwards to then go forwards. Edgar? Yeah, we have to distribute this here and here. And what will we get as a result of that? Alexandra? W squared plus 4w. And now look, minus 117 equals 0. And now look, now we have a trinomial that we can factor. So now we can do this. And we know that it's going to be a w and a w, but we have to find two numbers that multiply to negative 117 and add to 4. That's no easy task. Well, if you know your divisibility rules, it's actually very easy. Nathaniel, you found it already? Don't tell us. Don't tell us. You got it? Don't tell us. Well, I like the way I see some people with their calculators kind of experimenting. Like I said, if you know your divisibility rules, you should have found it right away. All right, Nathaniel.
W is equal to 9.
No. No, you're going too far.
Alright. W minus 9 times W plus 13.
W minus 9 times W plus 13. 13 times 9 is 117, and since it's a negative 117, one of these has to be negative. Then you have to make sure it adds to positive 4, so the 13 has to be positive. So this is what works. I knew immediately that this number was divisible by 9. What's the rule for divisibility by 9? Valerie? Yeah. 1 plus 1 plus 7 is 9. If the sum is divisible by 9, then the original number is divisible by 9. I instantly knew it was divisible by 9. You should have also. So now we've got the factors. Now we can set them equal to 0. And so what are the two solutions to this equation? Go ahead, Nathaniel.
W equals 9 and negative 13.
W equals 9 and negative 13. But now we have a real-world scenario. What's the width of the flag? I don't understand. I've got two answers. Does that mean there's two different possibilities? Maybe I can make two different flags from it? Ziamara? One's the length and one's the width. Okay. Which one's the length and which one's the width? You don't know? Okay. Well, does anyone know? John? 9 is what? 9 is the width. Why not negative 13?
Because you can't make a flag negative.
Why not?
Like, okay, say the flag is going positive numbers. Like, you're deflagging.
Deflagging? All right, well, John's making up new words, but I think I actually understood what he meant, strangely enough. What John is trying to say is that there's no such thing as a negative distance. There is no way that anything could be negative 13 inches or feet or anything. This answer doesn't make sense. So the correct answer is 9. The width is 9. So this is something that started last time we were together and is going to continue for the rest of the year. Is that you're going to start experiencing answers that don't work. Not all the time, but sometimes. And so you actually have to think about what you're doing. You have to answer the question. It says, find the width of the flag. Well, maybe you could have two different possibilities, but in this case, it does not make any sense. Does anyone remember last time what the answer was that didn't make sense? What was the scenario and what was the answer that didn't make sense? Fung? What was the scenario that we were talking about? Can someone help her out? Danielle? For what? What was the character in the story doing? Dalton? Jumping rope. And so it didn't make any sense for the answer to be 0 because the person jumped off the ground. Some time had to elapse, no matter what. So it didn't make sense. So we threw that answer out. Same thing's going on here, is we're throwing out one of the answers. Okay? Comments, questions, concerns? Okay? I have to modify today's lesson due to time, so that's my fault, not yours. You guys did a good job today. It's a lot to take in. Your homework tonight is page 604, 10 through 46 even, and 60 and 62. You're going to have another quiz next week. I don't know what day, and it's going to be 9.1 to 9.6. And you need to read the next section, very important.